Time-appropriate greetings and welcome back. Let's use Excel to compute the net present value of an investment offering regular, guaranteed returns every year. A startup asks for $800,000 in investments and promises $100,000 return per year for 10 years. Suppose that you also have the option of investing this money at 5% annual interest. Naturally, we wonder, is this startup a better investment, or would I be better off just investing this money at 5% annual interest? To find out, we're going to compute the net present value of this investment. To make our calculations easier, I've added the interest rate, 5%, so that I can reference it in our calculations. We set up the sheet by keeping track of the year, investment, return, net return for that year, the discount factor, and the present value. I will call present day year, year 0. I enter a 1 in the next cell down and autofill the rest of the 10 years. I enter $800,000 as an investment in year 0. In year 1, I enter my $100,000 return. I take that $100,000 return in year 1 and autofill it to the other 10 years. I compute the net return for year 0. The net return is the amount returned minus the investment I made. In year 0, I lose $800,000 because I've invested it in this company. I click this cell and double-click the green box in the corner to autofill it to the other years. All of the other years will have $100,000 net because I invest nothing but gain $100,000. Note that currency formats are red to mean negative. We've seen that before in the present value computations. Let's now compute the discount factor for year 0. I want to enter the formula for discount factor in year 0 in such a way that I can autofill it to the other years. The discount factor is 1 plus r. When I autofill this formula downwards, I need to make sure that the row of the interest rate does not change, otherwise the interest rate will go down when I pull the formula down. To fix this, I put a $sign in front of the 5. This prevents the interest rate reference from moving downwards when I pull this formula downwards. Turning to the formula, right parenthesis to the power of the year. At present, it has only been 0 years since I've invested this money. I hit enter and the discount factor is 1. That's to be expected since I don't have to discount anything that's already in present day. I autofill this formula to the other years and notice that the discount factor increases as time goes on. That is, because money devalues over time, this $100,000 is not going to be worth as much as this $100,000. So I need to discount this $100,000 more than I've discounted this $100,000. Finally, we compute the present values by dividing the net by the discount factor. No surprise that the $800,000 investment today is worth $800,000 today. I autofill this to the other years. As I said, notice that the value of the $100,000 is decreasing over time. $100,000 10 years from now is only worth $61,000 today, whereas $100,000 2 years from now is worth $90,703 today. Finally, we can compute the net present value, which I'll indicate by NPV. The net present value is computed by adding all of the present values for this investment using the sum function. The net present value is negative $27,827. Compared to investing money at 5% annually, this startup returns about $28,000 less. It would be better to just invest the money at 5% in a straight compound interest account. A natural follow-up question is, what would the break-even point be? When would investing this money at straight compound interest be the same as investing in this startup? We can guess and check by changing the interest rate. For example, changing the interest rate to 4% changes the net present value to $11,090. So a 4% interest rate would make this startup a better investment than straight compound interest. Since 5% was worse and 4% is better, that means the break-even point has to be somewhere between 4 and 5%. Instead of guess and checking, Excel has a tool built in that will allow us to find the perfect break-even point. That is, Excel will find the interest rate that will make the net present value 0. Remember that this is called the internal rate of return for an investment. To do this, we go to the ribbon and click the Data tab. We then go to the What If analysis and we click Goal Seek. Goal Seek is going to set a cell to a value by changing another cell's value. In our case, we want to set the NPV to 0, that's the break-even point, and we want to do this by changing the interest rate. So to set the cell to NPV, we click inside the box and click the NPV cell. Then we enter 0 in the to value. Then we click inside of the By Changing Cell box and click the interest rate. We click OK, and Excel tells us that it has found a solution. Excel has found the interest rate, which makes the net present value 0. We click OK to dismiss this dialog. Notice that the interest rate still says 4%. This is rounded to the nearest whole percent, so let's add some decimal places so we can see a more precise answer. In the ribbon, go back to the Home tab and go over to the Number Formatting bar and add some decimal places. We can now see that an interest rate of 4.2775% will give us a net present value for this investment of $0. The internal rate of return is 4.2775%. An interest rate of 4.2775% will make this startup have the same present value as just straight investment using compound interest. Net present value is a significant technique in making business decisions when comparing different investment choices. Thankfully, Microsoft Excel makes it easy to compute net present values.